Hello, this is Xinru. Today, in this video, we are going to take a look at question 617, Merge two binary trees. In this question, we are given two binary trees and we have to put these two binary trees together to cover one another. If some nodes are overlapped, then we will in the new tree we will have the same position as the total value of these two nodes, and if they are not overlapped, then the node will be the existing. We will counting the node value of the existing node in the same position. So let's look into our example. So here in our example, we have tree 1 and tree 2, and we have to merge these two binary trees together, and as you can see, the node 1 and the node 2 are both root node, so we merge them together, we get 3, and the left node of the root node is 3, and the left node of the root node is 2, so we merge them together and get 4, and the same goes to the right node, which we get 5. And in this case, if you look at the left node of the root node in tree 1, there is no overlapped node in tree 2, therefore we just write down 5 as the left node of the root node in our merged tree, and the same goes with node 4 and node 7. So it feels like we have two papers. In one paper we write tree 1, another paper we write tree 2, and then we cover the first paper with the second paper. If there are two values at the same position, then we will add them up. If there is only one value, then we will just write down the existing value. So after we get this idea, then we can think about what method should we use to implement this idea. So can we use iteration? Yes, we can use iteration in this case, but it will be kind of unnecessarily complicated, because if we use iteration, then we will need to use breadth first search to create a local array that stores the node value of every level in both trees, and then we need to find out. Then we have to look into the pattern of those array, and after that, after we process and generate new array, and we need to convert those arrays into our newly merged tree. And as you can see, it is very complicated and unnecessary. So in this case, we should use recursive function. And as we can know, to use recursive function, we need to consider the boundary cases. So for example, in this case, it is not guaranteed that two nodes in both trees in the same position will overlap. Therefore, we have to first check if they are overlapping, and if they are not overlapping, then we need to return the existing value. Therefore, in our merge tree recursive function, we first have to write two if statements. So first is if T1 doesn't exist. If the node T1 doesn't exist, then what will we do is we will return T2. And if node T2 doesn't exist, what will we do is we will return T1. And after this bound conditions, now we can write actual code that is about the condition that both nodes existing and they are overlapping. So in that case, we will first create a node variable, and this node variable will have the value of the sum of two existing nodes. So we will create the node as new tree node of T1's value plus T2's value, and we will build our new merged tree alongside with this node variable. So what I mean is that in this function, in this recursive function, we will build from the node variable. So node.left is equals to, so we will call the recursive function itself merge trees of T1 dot left value, sorry, left node of the T1 and the left node of the T2, and node.right equals to merge trees of T1 dot right and T2 dot right. And then eventually we will return the node. And let's submit our solution. And as you can see, it works. So basically, if we call these two trees, T1 and T2, so first, if T1 exists, we will just return T2. So that has two meanings in this bound condition. The first condition is merge trees has completed. Then we return the existing tree that will be our merged tree. And the second meaning of this statement is that if the nodes are not overlapping, and in that case we will return the existing node. So those two bound conditions serves the purpose of both overlapping cases and the completed state. And then we just create new node and we build upon the node.